everybody. Lou again. So I got this for my daughter for Christmas, and we went through the entire process as suggested by the instructions and came out with some really kind of depressing, very small matte finish rocks. So going onto YouTube, looking around a little bit, I found a channel called Michigan Rocks, run by a gentleman named Rob, and he finally went through and kind of explained the whole process. And it turns out that there are some changes that you need to make in order to achieve the results that we got. Using Rob's changes, if you look at this, we were actually able to get rocks that are shiny and not wet. In fact, it's kind of funny. I thought it interesting that the National Geographic instructions suggested putting a little mineral oil on the rocks to make them shinier. Right. So I just want everybody to know that without changing your machine at all, like I did, you're able to get these results. You don't necessarily need to do what I'm doing. The title of this is Slow Your Roll, and what Rob suggested was even on its lowest speed setting, this machine runs too fast, or runs faster than his machines and faster than he would like. So we're going to start the part of the conversation that I'll warn you. Anything that you do that I suggest most likely will void your warranty. So National Geographic, I wouldn't imagine would want to warranty something that wasn't the way it came from the factory. And you got to be careful because especially on the voltage part, where we talk about different voltages for the transformers, you can get the polarity wrong or the voltage wrong. And I don't think it would, I'm not too terribly worried about the DC motor. I am worried about the electronics that run here. So follow on from this point forward with care. The two things I did was change the voltage. I got a different transformer and change the size of the drive pulley. This is the one that comes with it. And I had a friend, thank you Doug very much, who's quite good with 3D printing, and he 3D printed a wheel with instructions that we found on the internet. So I'll put those links below. What we did was try all possible combinations of, well, not all, but the combinations of voltage that I selected and the wheel size, and then measured what the revolutions per minute were. Got a little mark here so I could keep track of what as the machine went around. And just so you know, this is a loaded wheel. All of these measurements were taken on a wheel that was about 2/3 full of rocks and ceramic media. So this is the fully loaded weight. So let's go ahead right to the cut to the chase here. So you don't have to watch the entire video if you just want to know what's going on. So we have two options, 12 and 10 volts, and two wheel sizes, small and large. And you can see anything in pink would be the new or different from standard. And you can see all the possible combinations. We started off at about 66 RPMs, and it's not an exact number. I was counting using a stopwatch on my phone, so there may have been some partial rotations in there. But this, I think, gives us a baseline with all the same errors that I introduced for each one. Then we went to 12 volts in the large wheel and got down to 54 RPMs. And then 10 volts in the small wheel to 54. Same thing, so I got about the same result with these two. And then 10 volts in the large wheel, I got to about 48 RPMs. This I've been running about 6 or 7 days. It did the final polish on these stones, and I do my post polish wash on this 48 RPMs with the 10 volts, and it's worked out just dandy. I haven't had any troubles at all. So we'll come back to this and talk about the power specs here in a minute, but let's talk about changing the wheel size and what that involves. So on the internet, I found somebody who had actually designed for a 3D printer a new wheel, and it worked beautifully. Doug was able to print it for me. He said it was a relatively straightforward process, and it came out very well. A lot of that can be attributed to Doug being very good at 3D printing. He's done it for a while. He's used the machine he's had for quite some time. And as the person who created these files for printing this pointed out, if your machine's not properly calibrated, you can have issues. That being said, there are some things you'll need to do to this to get it to fit and function properly. Probably the first thing that I had to do was the inside diameter of the pulley was a little too small. So I just wrapped some sandpaper around a stick, and it took about 2 minutes of sanding, and I got that diameter to where it would slide on and off the wheel snugly, or on and off the shaft snugly. The other thing that I did is I took a little bit of the ivory soap I used for the wash cycle and kind of rubbed it on the shaft, and that allows you to move these things on and off easier. Be careful though, you'll notice this is a solid wheel, and this one is, has airfoils really inside, so it's not as strong. You want to make sure you press and pull from the other side right on the center, not on the outside. That's a recipe for disaster there. My wheel slid off very easily. If it doesn't, you could use a couple of maybe butter knives. I wouldn't use anything like a screwdriver, and get on the back, and you can see that just with a little bit of effort, my wheel slides pretty easily. It's not a problem. The other thing that the 3D printer, the person who created that file pointed out was the band, the drive band on this smaller wheel was really kind of looser than he would like. So this wheel is about 5% bigger than this one, at least according to the person who designed it. And I've noticed that the band fits better and it doesn't slip. So that's another advantage of using this wheel size. Now let's talk a little bit about the power supply. So after I watched the video, I made a comment thanking Rob for all of the work, which is a tremendous amount of work he puts into these things. And then talking about some thoughts about slowing down the machine. And one of the thoughts I had was adding a resistor to the power supply. And I could have done that, but then you're hacking wires and you have some exposed wires, and the resistor might get hot if you get the wrong size. So more effort than I wanted to put into it. And then I realized that I'm kind of a power transformer or a power junkie. And I'm one of those crazy people that actually has a whole entire box of power transformers. I get these at Salvation Army. I paid $1.99 for this one. And this transformer happens to be a 10-volt transformer. So it's slightly less than the 12 volts that comes with it. And it has the same polarity. So what does that mean? You'll see on the transformer, I don't know if our camera lady can zoom in, but a little diagram right there. And that diagram points out the center pin is positive and the outside of this plug is negative. And that's what you want. You want a polarity that's positive in the center and negative on the outside. That's important, very important, because you don't really want to reverse it. It might damage the electronics in the machine. Why did I pick 10 volts? Because that's the only one I had with a plug that would fit with the right polarity. So my big box of transformers happened to have this plug in it. So that's what I started with, and it turns out it worked pretty well. So some things to think about when you're looking at these. You want to kind of keep the total output, the watts, roughly the same, as close as you can get. Because the watts, if you've ever paid an electric bill, they're what's doing the work in Watt's law. And you want to kind of keep that the same so that the machine can do the same amount of work. What I did notice though, since this is a 14-watt power supply instead of 12, is this got a little warm while it was running. This, I couldn't feel any heat at all. The trick is you want to keep as close to this number as possible. You don't really want to over amp it, too many amps, too much current. That could be dangerous and might damage the machine. So keeping it, in the same general ballpark in terms of power produced while lowering the voltage got my RPM to drop. So what you're looking at here is Watt's law. So it's volts times amps equals watts. And you can do that for any power supply that you've got. So we were at 12 and 1, we're at 10 and 1.4, so that's 14 and 12. The other measurements that are really critical, if you decide to, you can buy these kind of power supplies anywhere from $10 to $20 on Amazon. But you need to know that it comes with a plug that will fit inside the machine properly and the right polarity. Now, a lot of them have polarity changers, so you can just change the polarity if you want to. But you'll need a plug anywhere about 5.5 millimeters on the outside. So this outside of the plug would be 5.5 millimeters. And the inside, you've got a little bit of wiggle room, anywhere between 1.5 and 2 millimeters. I would find that would fit perfectly well. I'll talk about how I pick plugs when I'm remotely in a remote place too, because it's a little bit difficult. If you don't want to carry around a gauge, you'll need to have a method to pick the right size. So let's talk about that a little bit. So in order to get the right polarity, all the plugs have these little diagrams on there. Now your eyes might not be good enough to read this. You might want to bring a magnifying glass, because on smaller plugs like this, they're very small. So that'll help you get your polarity right. And then for me, what I do is, instead of hauling you could take the entire thing with you, I guess, and try them, is I find something that fits snugly inside, and then something that fits relatively well on the outside. So I know that's a little loose there. So what I'm going to do is take these two items with me, and as long as they kind of meet those conditions, and you can see on this one, the original one, it's pretty close. Then as long as you meet those two conditions, it's going to work. So then that's where I got the 5.5 and approximately 1.5 to 2 millimeters for the inside pin diameters, by doing this and then just measuring whatever I fit in there. This happens to be a drill bit, and this is a washer. I think it's a 1/4 inch washer, maybe, pretty sure. But that's how I figure out which one is which when I go in to buy them. So just wanted to touch base with everybody and thank Rob again for all of the videos. Like I said, you can watch his videos and not make a change to this machine and get beautiful results. And for most of us, that's going to be fine. I'm kind of like different options for different speeds. I might change, the options, the 1, 2, 3, and 4. I might use one of the middle options to get a little faster speed for the first iteration, the coarser grits, so that it works a little faster, and then switch down to the lower version. And I can do that just by changing the power supply that I use. So appreciate it. Thanks again, Rob. Thanks again, Michigan Rocks, for putting that video together, and looking forward to creating a lot more beautiful rocks. Thanks, everybody. Goodbye.